It's my pleasure to introduce Connor Graham. Connor is a senior DevOps engineer at Bitovi, passionate about automating everything and creating self-service tooling for development teams. He has experience solving DevOps problems at all scales, from startups to enterprise. When Connor's not busy working on client solutions, he's contributing to open source projects and creating free content to share DevOps knowledge with anyone who will listen. In his free time, he likes Formula One, craft beer, and being a parent. His talk today is maybe you don't need Kubernetes. Connor, floor is yours.
So, hi everyone. Kubernetes is a pretty cool tool. It's been around since 2014, and a lot of tech evangelists out there will treat it as like the Swiss Army knife, the tool that can solve all problems. And you know what? I disagree. So let's jump right into it. First of all, I'm no hater. I love Kubernetes. I've built a large part of my career around Kubernetes. Having native support for replication, rollout strategies, self-healing, there's extensibility around the operator framework, and all of this checked into like a well-defined YAML schema in a Git repository with automated pipelines to deploy it all out is nothing short of magical. But with all of that, there is a cost. There is a tax associated with Kubernetes. Kubernetes is not as straightforward as some may lead you to believe. Working for some of the largest companies in the world, building and operating Kubernetes clusters typically have a team, if not many teams, around building this platform for developers to consume. Here's the crux of my whole talk. Kubernetes is an economy of scale tool. If you are trying to operate 10, 20, 100,000 microservices, Kubernetes is the best tool for the job, without a doubt. But if you're on a much smaller scale, the tooling associated with just trying to have a successful Kubernetes cluster around observability, having a service mesh, installing Prometheus and Grafana for metrics collection, Elk and Loki for collecting and aggregating logs, all of these tools that you need to install to have a good production grade cluster. The cost, both from compute as well as man hours, can typically start to outweigh the man hour and compute costs that go into just managing the service yourself. And so even on top of that, like local development with Kubernetes is difficult. There's a lot of like great tools out there that people are trying to put out there to make it a little bit easier. There's like Minikube for running local clusters. Docker Desktop has something natively. Rancher recently released a tool, but more often than not, I see local development teams using something like Docker Compose to run their containers. And that creates an issue where your config is now fragmented. You have a set of config used for running your services locally, and then you have a completely different set of config for running things on like an actual cluster. And that fragmentation or that difference in config has a management overhead, as well as you can run into some issues trying to go from local to like your real deployed environment. Other solutions I've seen out there is like there's pull request environments. So when you create a pull request on your code, it creates a temporary ephemeral environment that allows you to test your change, and then on merging your pull request, it tears down that environment. And I've also seen teams that do all of their development against a remote cluster. There's some really great tools out there like Scaffold for this sort of thing. But going back to my previous point, it's an economy of scale thing. Like if you're just trying to get a service out there and deployed to the world, trying to manage all of these things requires a lot of man effort to put together. So I want to look at different areas of the stack and try and point out some really good and viable alternatives. Starting with the front end, if you're just trying to get something out there, there's nothing better than like your neighborhood friendly pass. Something like Netlify, Heroku, make it dead simple to just like sign up on their account, push something to a Git repo, and then it deploys it and it's out there in the world. A bit of a hot take here, even if you are operating a Kubernetes cluster, I think it is incredibly wasteful to host a static front end on Kubernetes. Static front ends are relatively straightforward, and there are better solutions out there. The real optimal solution, I think, that I would suggest here is AWS S3. It is incredibly straightforward to get started with AWS S3. It's Amazon's object storage tool. They provide static website hosting, and it is probably the most durable and available thing on the entire internet. It is awesome. It's very easy to get started with. It's a little code snippet at the bottom. It's literally 3 commands to get started. You use the CLI, you create a bucket, you update the permissions to make it publicly accessible as a website, and then you just sync your local content up there. You build a pipeline to do this, you're good to go. You have like one of the most durable websites out there. It can further be scaled to like, you can have DNS entries that point to it. You can set up like a free SSL certificate. It's a really great baseline, and it's really easy to scale out and introduce more things as you need them. Moving on to backend, same story here. Your friendly neighborhood pass is going to do a great job getting you up there and running. But what I would really like to sort of suggest, and it's a bit of a paradigm shift, so it can be difficult to really adopt, is serverless. When we're in the age of microservices, where you're breaking up your monolith and you now have like a coupling of functions as a microservice, related domain functions, serverless takes that one step further, and it puts you into like things are separated onto like independent functional levels. And this gives you a really powerful framework to work off of. And if you haven't looked at serverless in the past 2 or 3 years, I would encourage you to go back and take a look, because a lot of the valid criticisms of the past, things like cold boot time, things like running your function locally, so you can actually like develop against it, and like code sharing between Lambda functions or any sort of serverless function, have all been resolved. It's all like a very great experience now. There's a serverless framework out there that allows you to build a serverless function and deploy it to any one of your common serverless providers, your Google, your Azure, your AWS. And similar to S3, there's a little block of code at the bottom. Very easy to get started. Install serverless, serverless deploy, serverless invoke. It's that easy. Moving on to persistence. So if you take one thing away from my talk, you can ignore my front end advice, ignore my back end advice. My advice for persistence: please, please, please use a managed database service. Self-hosting a database is a nightmare. It's to try and build up your availability and resiliency requirements, backing up, restoring, having any like visibility into what's actually going on to your database is very difficult when you host it yourself. Doing this on Kubernetes is even harder. Kubernetes has native support for persistent volumes and persistent volume claims, but I've spent many an hour trying to diagnose these issues. I would argue it just makes it harder, not easier. So I would definitely recommend, if the database technology you're looking at using has a managed service equivalent, something like AWS RDS, use that, please. Save your friendly DevOps engineer and use a managed service. And so to wrap things all up, I just want to say there's no perfect solution. I did suggest AWS for a lot of these different stacks here, but AWS isn't without its own set of valid criticism. Ultimately, what I want you to take away from this is you should treat your infrastructure with the same care and consideration that goes into your application code. This means checking it into a Git repository, having pipelines, like using infrastructure as code like Terraform and Ansible to like spin all these things up and have it managed. And really doing so is going to give you the second point. It's going to allow you to be really flexible. And whether it's Kubernetes or whatever comes down the road next in a couple of years, you should be poised in such a way to adopt what is ultimately right for you at any given time.